Our next bit on variation, we're going to look at data, and we're also going to find the constant of variation, and then use that constant to complete a chart of information. For our first example, we're looking at data for weight. In our chart of information, we see a column of pounds, and we see a column of kilograms. When I look at the values for pounds, 10, 25, 50, all of the values are increasing, so I'm going to draw a little up arrow. These are increasing. When I look at the values for kilograms, 4.5, 11.4, etc., these values are also increasing, so I'm putting a little up arrow for these as well. Now, because they are both increasing, I know that this is a direct relationship because as one item increases, so does the other one. That means that I can model this with a direct variation equation. I just have to determine what my letters stand for. So I'm going to use P for pounds. I'm going to use K for my constant. And I'm going to use M for the kilograms. I don't want to use K because then I'd have two Ks. So M, thinking M for the metric weight. And so I can write an equation. Pounds came first, so I'm going to have P equals. I know that K always follows the equals, and because I determined that it is a direct variation problem, it will be K times the metric weight. Now I have my formula. I'm going to use this for the rest of the problem. I'm going to take a value for pounds. I'll use the first value of 10, and I know that that is related to 4.5 as the metric weight in kilograms. I can solve this equation to get K by itself by dividing by 4.5 on both sides. These will cancel. Divide by 4.5 here. And so K equals, grab my calculator, and so we are doing 10 divided by 4.5. 2.2 repeating. Now, we know that K is constant. So if I picked a different row of the chart, I should get the same value for K. But let's try it out. I'm going to take the second row of the chart. So in the second row, going back to my formula, the P, the pounds are 25. The K we think is 2.2 repeating. And we're going to check that out. So I'm still going to use it as a variable. And I know that the metric weight is 11.4. So to solve this one, I divide both sides by 11.4. And I go to my calculator. 25 divided by 11.4. Ooh, I did not get exactly 2.2 repeating. Instead, I got 2.1929, and it continues. 2.1929 continuing for K. So this kind of violates my idea of constant, because constant should be the same number no matter what. But when I look at these two values for K, they're slightly different. However, they can be rounded to the same value. They both could round to the whole number of 2, or they both could round to 2.2. However, if I try to round at the hundredths position, then I'd have 2.22 versus 2.19, and they would be different. So because K is constant, I have to pick a value that these both round to, and so I will pick 2.2, which we actually memorized as a conversion between the metric and the pounds. The reason why the K's varied a little bit different in their unrounded form is because of the rounding in this chart. So if I started with the different pounds values, and it looks like I would have because they're whole numbers, and then found the equivalent kilogram values, these are approximations because no scale is going to be precise to all of the decimals. So these values, both in pounds and kilograms, would be approximate values and would be considered rounded values. And so that's why our K varied a little bit, But because we understand a constant cannot change, we have to pick a value that k can round to on a consistent basis, and 2.2 works. We could test this by looking at all the rows in the chart, and we're not going to go there, but we could. So we have found our constant of variation, the first thing we were instructed to do, and now we're instructed to complete the chart. So in my chart, the last weight in pounds, 235 pounds, the metric weight is missing. So again, I'm going to go back to my formula, pounds equals k times n. So my pounds here is 235. My k value is 2.2. And my metric value is unknown to me at this moment. So to solve this, I divide by 2.2 on both sides. And I go to my calculator. So 235 divided by 2.2. And based on the rounding for the rest of the chart, I will give an answer of 106.8 kilograms. And so I have used my variation equation, which is right here. Really, really important. Always going to ask you for this on a test or quiz. I have defined my variables, really important, so that anybody using your equation will use it correctly, putting the right numbers at the right place. Found my value for k, and then I utilized that value in this last step to complete the chart. So we're going to go through a second example, and our second example has data for melting an ice cube. So I start by looking at my data. The temperature in Fahrenheit seems to be, yes, going up the entire way. So I put a little up arrow. Then I have hours. When I look at the hours, they are decreasing. So I put a down arrow. So as one thing goes up, the other thing goes down. And we recognize this as an inverse or indirect variation relationship. So that tells me how to set up my equation. I just need to know the letters. So I'm going to use T for the temperature. I'm going to use H for the hours. Temperature is listed first, so T equals K. K always follows the equals. Then since we decided that this is an inverse relationship, I'll use division, so divided by H. I'm going to take the first line of my chart and fill it into my formula. So 35 is equal to K divided by 3.71. So in order to solve for K, the constant, I'll need to multiply by 3.71 on both sides of my equation. So I'll go to my calculator, and we have 35 times 3.71, and we have a value for K as 129.85, and it continued. Good estimate. Like the previous problem, we're going to repeat this calculation with the second pair of numbers. So my second pair of numbers, going back right up here to this variation equation, using that same formula every time. So temperature 50, K is what we were double checking, and our hours here are 2.6. So I'd multiply by 2.6 on both sides. Go to my calculator. 50 times 2.6. And I get K equals 130. So again, I have a little bit of variation between my two K values. Double checking them, they both would round to 130, so I'm going to use that as my K value. So I found the constant of variation, first thing it tells me to do, and now I need to complete the chart. So in the chart, a temperature of 100 is equal to, using my formula, K, so 130 divided by H. Now, it's always a little bit challenging when h is in the denominator. So one thing that we can do is put the 100 over 1, and then I truly have a proportion where I can cross multiply. So on this diagonal, I have 100h. On this diagonal, I have equals 130. Divide both sides by 100. And so I get h is equal to 1.3, and that would be hours. So I can complete my chart 1.3.